Hello and thank you for watching. In this video we're going to try to build some intuition for the definition of the limit. Okay, so to start off, let's say we have some function, and if we graph the function, say we have something like this maybe, and okay, say when we're approaching some value a, it has a limit L. Okay, so now if we think about some distance from L, say we have this distance epsilon here, and then this same distance epsilon here. Now clearly if we keep reducing the size of this epsilon, then eventually we're going to squeeze it in so close to L such that the value of L plus epsilon is going to approximately be the same as L. So we're getting closer and closer to our limit as we decrease our epsilon. Okay, similarly, if we have some delta, then similarly, if we keep decreasing this value of delta, we'll go closer and closer to A such that A plus delta will approximately be A as delta gets really, really small. Okay, so now I'm going to propose an idea. If we're given some epsilon, so given some epsilon greater than 0, because obviously this is not going to be negative. Say we're given some epsilon greater than 0, then I'm going to say that there exists some delta for which this limit is contained within this interval. So this is my proposal. Or rather, I'm saying that if we're given some value away from this limit, some epsilon, then I can tell you some delta, which we can find a range of inputs that would pop out an output within this distance from the limit. So basically, if I said that, for example, we had epsilon equal to 5, for example, we'd have, this is a L plus 5, this is a L minus 5 here. So what I'm saying is we can find some delta such that we still have every value within this range here, such that it's contained within our range of outputs. So we're basically observing the behavior around A and not at A. We're looking at everything that can happen inside of this. So more or less, I'm saying that given a value away from the limit, we can always find a value away from the input such that this distance epsilon away from the limit is within our delta, or rather Yes. So this kind of leads to our definition of our limit. So essentially what I said, that if we're given some epsilon greater than 0, then there exists some delta such that if we have some distance less than delta, then we have that the distance from the output to the limit is less than epsilon. This is what we essentially stated. So we're saying that given some value of epsilon, given some distance away from our limit, less than epsilon, we have some delta such that the distance away from our input to A is less than delta, implying that we can find some distance less than epsilon with the limit inside of it. So I'm saying that no matter which epsilon we take, we can make it however small we want to make it. We can make it equal to 0.001, for example. I'm saying we can still find some delta. Let's say delta is also really, really small for this reason. Say it's 0.05, for example. We can say that this little distance here, if we zoom in a lot, we'll have like some, or rather we'll have some sort of a point here. This is still our A, but then we have these two values at either side, 0.05 here, 0.05 here, and we're saying that we can still go within our range, where we have the L here, the L plus 0.001, L minus 0.0. So we're saying that despite having this, we can still find some value of delta that's contained inside of this interval. So this is basically a restatement of what we're saying. If there exists some value of delta, well, if the value from A, well, if the distance between A and the input is less than delta, then we have that the distance between the output and the limit is less than epsilon. And that is exactly where the limit definition comes from. We can write this compactly as saying limit is x goes to A of f of x is equal to L. That's the end of the video. Thank you for watching. Hopefully this helped you understand where the definition comes from, and if it doesn't, then there will be another video with examples of its usage, and hopefully that will help you build some intuition. That's all. Bye bye.